Hey, what's going on, everybody? My name is Alan Kleiner. I'm currently a student in the College of Engineering at the University of Illinois at Urbana-Champaign, studying computer science. As a Wolfram intern, I have been fortunate to attend numerous hackathons across the country, and even before that, I've been fortunate to go to hackathons in Michigan, Pennsylvania, and even most recently in Arizona. So over the past several months, in meeting with various people here at Wolfram, we thought it would be pretty interesting to bring some of the exciting technology that we have going on here to the hackathon community and bring hackathon activity to members of the Wolfram Language community as well. So today I'm going to be sharing a little TripPlanner project. It's something that I got inspired to do after traveling to Arizona this past weekend. And I'll show you guys step-by-step process that I went through to kind of get from point A to point B, intermediate steps, etc. And hopefully in the process, I'll be able to show you guys just how powerful Wolfram Language code is and how easy it is to deploy it through the Wolfram Cloud. So first, though, let's get started with a little presentation from Chip Hurst showing you guys how to quickly get started with the Wolfram Programming Cloud. So here's Chip.
Hi, I'm Chip Hurst, here to show you how to get started with the Wolfram Programming Cloud. The Programming Cloud is an online development environment accessible from your browser where you can write and deploy programs in the Wolfram language. I'll show you how to get online, how to use the Programming Cloud interface, and how to write and deploy programs in the cloud. To get started, go to www.wolframcloud.com and click Wolfram Programming Cloud. You'll see the sign-in screen. If you don't already have an account, click Create Account to get one. Anyone can get a free Wolfram Cloud account with a basic level of access to the Programming Cloud. Sign in to the cloud with your account name and password, and you should arrive at the home screen of the Wolfram Programming Cloud. The items on the left are resources and shortcuts to help you get to work, and the ones on the right are something similar to a file browser where you can manage your cloud objects. To get started writing code, click Create a new notebook. Give the notebook a name by clicking here. Notebook documents are where you write code in the Wolfram Programming Cloud. They're useful for a number of other things as well, like making presentations and testing code, but I'll focus on programming here. If you're familiar with Desktop Mathematica, you'll feel completely at home in cloud notebooks. If you aren't yet familiar with the Wolfram language, stick around, I'll show you how it works. You can use the Wolfram language in the cloud like a calculator. Type an expression, like 100 factorial, and evaluate it by hitting Shift-Enter. You immediately get an answer. The input and output reside in cells, which are indicated by brackets on the right. Hover over a bracket and you'll see a gear icon that you can click for a menu of operations useful for managing cells. There are lots of kinds of cells which you can mix freely with inputs and outputs to document your work and give structure to your calculations. Add a text cell to document your work by clicking the input tongue and selecting plain text. Add title and section cells to structure your notebook. The cloud interface has a lot of helpful features that help you find your way around the Wolfram language, like this toolbar that appears after you do an evaluation. It's called the Suggestions bar, and it contains operations you might want to do next on the output you just got. It helps you get work done quickly and learn the Wolfram language. If you click, for example, prime factorization, it will not only give you the prime factors of this huge number, but also show you what you could have typed to get the same result in the Wolfram language. Now you know that factor integer is the function that gives you the prime factors of a number, and that you apply the function using square brackets. So you can type factor integer of 100 and hit Shift Enter to get prime factors of 100, namely 2 2s and 2 5s. If you don't want to see the suggestions bar, click the X at the right to minimize it. You can always get it back again by clicking the arrow. For those of you who are completely new to the Wolfram language, you don't have to know the specifics to get something done. You can program using natural language. For example, enter today's date by typing control equals and today. When you evaluate that expression, it will turn into what you could have typed with exact Wolfram language syntax to specify today's date. You can use natural language input right in the middle of calculations too. Say you want to know the number of days since the beginning of the year. Type control equals today, enter, minus control equals Jan 1. Hit Shift Enter to evaluate, and you see the answer. You can switch between the natural language expression and the exact Wolfram language expression by clicking here. There are several code assist features in the cloud interface that help you use Wolfram language functions. When you start typing a function name, a completion menu pops up with likely names that you intend to type. Type return to complete a function name with the item selected in the menu, or click the name you want. Click the down arrows that pop up next to a function name to select an argument template. Type the arguments using Tab to advance to the next placeholder. You can get complete documentation for a function by hovering over the function name and clicking the I. The documentation appears in a pane to the right of the notebook. You can work with the notebook and the documentation panes side by side for quick access to function descriptions. The easiest way to learn the Wolfram language is to copy and paste examples from the documentation to try things out. You can explore by editing the example inputs as well. A faster way to do the same kind of exploration is to use manipulate to make the example interactive. Wrap the expression in manipulate and replace the value you want to explore, t in this case, and specify a range of the variable. Now you have an interactive widget that you can quickly use to explore variations in the example code. You can get a lot of work done just by evaluating these kinds of simple one-line expressions of built-in functions. But the real power of the Wolfram language comes into play when you define your own functions. Here's how to make a function that returns how many days ago a particular date was. I'll call the function daysago and give it an argument of date. Evaluate that definition with Shift Enter. Now you can use the function by invoking it with a particular date. For example, Jan 1. Now let's make that function available to the world by deploying it to the cloud. Type cloud deploy form function, specify the argument date is a date, and make the deployment call the function days ago with the date argument. When you evaluate Cloud Deploy, you get a Cloud object. Click the link in the Cloud object and you get a form where you can enter a date and get the result. The form contains smart fields. You can enter any common format for a date and it will interpret the result. If you give it nonsense, it will let you know. You can make a function that evaluates directly without the intervention of a form by using API function instead of form function. You call this function by specifying the date as a query string in the URL. You can also call this cloud function programmatically from the Wolfram language using URL execute. And you can do it anywhere in the cloud or from the desktop. I'm going to switch to Wolfram Desktop and call this function from there. So you have a function that lives in the cloud but can be used in the Wolfram language just like any other function. In fact, you can call this cloud function from just about any programming environment. To call the function from Python, for example, evaluate with embed code using Python as the second argument. You'll get the Python code that you can drop into your project to call the function. You can also put computed content in web pages using Cloud Deploy. Here's a web API that gives the current temperature. Click the link and you can see the current temperature. Right now, this is a private API accessible only to me, but you could make it accessible to the world by adding public permissions. To embed this on a web page, you apply embed code to the cloud object. Copy the HTML expression in the output and paste it into the HTML source for your web page. When you open the web page in a browser, it shows the current temperature at the location of the visitor. The embed code gives a default size for the iframe and frame style. You can edit that to improve the appearance of the page. So now you know how to get online, write a simple Wolfram language program, and deploy it in the cloud. The notebook and cloud objects you've been working with are listed in the Cloud Files browser on the right. Under Home, you'll see the notebook we've been working in. The cloud deployments I made are listed under deployments. For example, here's the web form that we made. You can track your cloud usage in the usage dashboard accessible from the Programming Cloud homepage. It shows you how you've used your cloud credits and how many you have left. You can learn more about the Wolfram language and what you can do in the Programming Cloud by visiting the Wolfram language examples that are linked from the Programming Cloud homepage. Each example contains Wolfram language code and an explanation of how it works. You can try the code yourself in your cloud account by clicking the Open Live Version button at the top of the example. For help with Wolfram language questions, try visiting the Wolfram Community page, which is also linked from the Wolfram Programming Cloud homepage. Community is a group of over 7,000 people and growing who discuss Wolfram language and other Wolfram technology issues. Members can often answer questions, and you'll also find lots of interesting applications of the Wolfram language there. If you try out the Wolfram Programming Cloud, let us know how you like it by sending us a message with the feedback button. I hope you enjoy exploring. You can do incredible things with the Wolfram language, and now that it's in the cloud, it's easier than ever to use it. Let us know what great things you do.
Okay, now that everybody has been introduced to the Wolfram Programming Cloud, we can go ahead and take a look at my hackathon project. And for those of you who might not know what a hackathon exactly is, it's simply put, it's just a 24 to 36 hour coding competition where you can make anything from scratch. So I kind of wanted to lay that little definition out there for those of you who might not be familiar. In addition, I wanted to, before we get started, invite you all to hopefully full screen it. Feel free to ask questions. We want this to be as interactive as possible. And so, yeah. Now I'll go ahead and get started on the project. And as soon as that's ready to go, I'll have a couple of developers join me for code review, for potential improvements and feedback from them. So yeah, if you have any questions, go ahead and ask them in the Q&A pod. But other than that, we can go ahead and get started. So yeah, all right, let's go here. Okay, awesome. So like in the video, if you go to wolframcloud.com, you can go ahead and see here we have a couple of options ready to go, but I'm going to go ahead and select the Programming Cloud, and I'm going to go ahead and log in. Okay, great. So this is the primary interface for the Wolfram Programming Cloud, as you guys probably saw in the video. So there's another video here if you guys want to go ahead and get started again. And if you guys also just want to play around with some of the examples, see another fast introduction for programmers, et cetera, et cetera. Or if you want to just go ahead and create a new notebook, which is the primary interface for writing Wolfram language code, you can go ahead and do that. I already have a notebook ready to go, so I can go ahead and I'm going to go ahead and open it here. And as soon as it loads. Awesome. Cool. So I'm going to go ahead and get started walking you guys through some of this code. And so, yeah, I'll just go ahead and get started, answer questions hopefully along the way, but I'll just try to keep going through and see if this goes all right. So for starters, like I said, I wanted to have a TripPlanner function. I want to make a TripPlanner app of sorts. So we're going to go ahead and declare a function called TripPlanner, and we're going to give it 3 parameters. So namely, we're going to give it temperature, we're going to give it wind direction, and we're going to give it wind speed. The idea of this TripPlanner is that if you ultimately we're going to enter 2 cities, and evaluate them against each other. And you can see, city 1, here's the temperature, wind direction, wind speed. City 2, here's the temperature, wind direction, wind speed. It's super simple app, but you can see just how quickly and how easily it can get deployed to the cloud through here. But so for starters, we're going to head, like I said, we have 3 parameters: temperature, wind direction, and wind speed. They're followed by an underscore to declare that they are parameters. And then this is our little notation for this is start of a function. So now we have a width function, and essentially what width does is you can provide it a variable here, and in any instance that it sees with the variable somewhere in there, it's going to go ahead and replace that variable definition with its value. So in this case, I'm providing its size, and I'm saying 100. And specifically, I want to provide it so that later on here, which I'll get to in just a couple seconds, that our images remain a pretty consistent size of about 100 all around. So now I want to start a row. And within that row, I want to have the following things. So in here, I want to have this icon data of air temperature evaluated at temperature, which is our variable. And I want to show that with the image size of size. So specifically, I can actually go down here. Let's go ahead and show what icon data could do. So let's provide it air temperature, and let's give it, let's say, 15, and it should come back. So that's essentially what icon data looks like. If you want to see something else, so let's see wind direction, we can go ahead and evaluate that using Shift-Enter. Bam, there you go, same idea. It goes ahead and interprets this 15 as its input, and then adjusts the icon accordingly. So yeah, we're going to go ahead and do show icon data for air temperature with the variable temperature and evaluate that image size. And now we're going to delimit each of our things in the row by a comma. So we're going to have comma, and again, show icon data wind direction with the wind direction parameter. Again, evaluate it at size. And then finally, once again, we're going to have show icon data wind speed parameter, image size as size. And for those of you guys who want to take a look at what the wind speed icon looks like, let's go ahead and evaluate that. Same idea, it just, instead of having the direction, it just throws the number in that icon as well. Okay, awesome. So now that we have our initial function definition, we can go ahead and evaluate that, and it will be ready for us to use later on. So we're going to go ahead and evaluate this cell, Shift-Enter. And it should have evaluated. To prove that it evaluated, we're going to go ahead in here, we're going to type in TripPlanner. Let's say our temperature is 80 degrees Celsius, it's a hot day, wind direction is, I don't know, let's say 20, and wind speed is 45. I don't know where you'll ever get degrees and that wind speed, but oh well. And so bam, there you go. And that's exactly what we wanted. So we wanted to specify and put everything in a row and then display those icons accordingly, all in a row together. And that's exactly what we wanted. So now, given all of that, we want to actually then go down here and hold on 1 second here. So I'll add these in later. Oops. So now we want to actually have our overarching TripPlanner function. Like I said, we want to give it a location, first location and a second location, and then we want to have it display that accordingly. So again, same notation as above, specify its parameters and give it an underscore to ensure that they are parameters. And then we're going to, again, signify the start of a function. Now, we're going to wrap them in a column. So the idea behind this is that we want to stack, we want to stack for one city, we want all of that data, and then for the second city, we want all of that data as well. And then you're going to see here, we're also going to have a distance between 2 points, which I'll actually get into right now. So here we're going to specify a new row. within our column, and we're going to provide it the text the total distance is, as well as this GeoDistance function between location 1 and location 2. And we can evaluate here. So we can go ahead and call GeoDistance. It takes in 2 entities. So like in the video, we can hit Control Enter, and let's give it, let's say Houston as 1. Ooh, that's not where I wanted to go. Houston, awesome. And I don't know, Chicago, let's say. And give it a second to see what that is. So if I hover over both of these, you can see that the actual Wolfram language code for this ends up being entity of city, specifically Houston, Texas, United States. Similarly for Chicago, entity of city, Chicago, Illinois, United States. So now if we evaluate this, give it a second. There you go. So the distance between Houston and Chicago is 899.246 miles, although it's 899.246. So anyways, yeah, let's get back to up here. So now you know what the GeoDistance function does. And now we're going to specify again in our columns, we're going to provide the first thing, I guess, if you will, TripPlanner. So we're going to make a call to our TripPlanner function up here. And specifically, we're going to provide it the weather data call for location 1, temperature. So that matches up here. We're going to then call, again, weather data wind direction for location 1, matches up there. Weather data location 1, wind speed. And we're going to call the TripPlanner function on all of that, and that'll render as one entity in a column of itself. And then similarly, you can probably imagine for our second column, we're going to go ahead and call TripPlanner again, and we're going to go ahead and provide the exact same things. We're just going to give it weather data of location 2, temperature, weather data location 2, wind direction, weather data location 2, wind speed. And now that's all set up just fine, and we can go ahead and wrap that and finish that in our column. So now let me go ahead and evaluate this so that we have now the new TripPlanner definition in our code library, if you will. Cool, so that seemed to work. I'm going to go ahead and get rid of this for now. So we can go ahead and call TripPlanner. Again, control equals, let's go ahead and do Houston. So bam, comma, Chicago, bam. Cool. So from this, you should essentially see, or we should essentially see, the output, which would be just the total distance, and then a grid of these stacked upon each other, like we said here in this column call. And by providing it, TripPlanner entity is one entity in the column, and then this is a new entity in the column as well. So let's see how this goes. It's going to be, give it a second here. So there you go, perfect, initializing city data indices and weather data indices because of our weather data calls. These tend to be a little bit slow for whatever odd reason. There's a lot of data it needs to pull in. It's doing things. Awesome. Cool. So total distance is 899.246 miles, like we had seen before. And then it stacks up here with temperature, wind direction, wind speed, temperature, wind direction, wind speed. Awesome. Now, we could end it there, but that's no fun. Let's actually go ahead and deploy this to the cloud as a web form. And it's an instant web form that anybody should be able to access. And from there, they can enter their own inputs, and it'll evaluate accordingly. So we're going to go ahead and use the cloud deploy function. And for those of you guys haven't maybe noticed already, there is built-in autocomplete into the programming cloud. So if you type in cloud, it gives you everything that starts with cloud. But we specifically want to use cloud deploy. And again, here's form or auto-completing, whatever. But I'm going to go ahead and skip through that. So we want form function, we want to deploy a form, and now we want to give it, let's say, 2 parameters. So city1 is, let me close that, is a city, and city2 is also a city. Oh, sorry about that. City. Cool. So we specified our parameters. We want to give it a function to evaluate at. So we're going to go ahead and say TripPlanner, perfect, of now hash city1, hash city2. Evaluate that. We're going to close that there for the form, and we're going to close the cloud deploy as well. So that being said now, let's also give it actually an output to render as, let's say, PNG. We want to render it as an image. Okay, so let's deploy this to the cloud now. Hopefully this works. Awesome. So let's give it Houston, Chicago. Remember, as you saw in the video, these are Wolfram Smart Fields, aka if you provide it something like City of Angels or anything that can identify something as a city, it'll interpret that properly. But obviously, if you provide it something like chicken, it'll say you're wrong. And so that's really nice to have built into the form, automatic, error checking, things like that. So if we submit this, give it a second to evaluate everything, and hopefully things went all right. I'm really hoping this goes all right. Still loading, and huzzah, there you go. That's exactly what we wanted. We can add things to this, such as, let's say boundaries, or let's add a little bit of padding around here. We make it bigger, whatnot. But for just a basic, simple starter project, you saw how quick and easy that was. And so, yeah, I think that would be kind of just the basics of it. So hopefully you guys saw just how quick and easy it is to deploy from the cloud. So yeah, I'll think we're good to go from here for now. So let's get some feedback. I'll let Chris Carlson go ahead and introduce the developer panel. And once again, I wanted to say thank you guys for being here today. We're going to go ahead and jump into the introductions of everybody and get started with the code review.
Okay, thanks, Alan. That was a great demonstration of how quickly you can deploy an app with the programming cloud. And you can do it all in the browser, right? The development, the deployment is all in a browser. Using it, all you need is a browser. So we've put together a panel of senior developers to comment on what you just saw. So sitting to the right is Joel Klein, who's a kernel architect. And joining us offsite is Bob Sandheinrich, who is a software engineer. And I'm Chris Carlson, a user interface developer. So, gentlemen, do you have any comments off the bat?
Well, it's a cool demonstration. One thing that I would love to see is just the names of the cities for the two bars of icons. Which one's which?
Yeah, oh true, yeah, I did not think of putting that in. I can put that in now and redeploy if that could work.
Yeah, sure.
We can go ahead and just type in location 1 and then down here, location 2. And then once again, if I go ahead and reevaluate this, and then I'll reevaluate this cell as well, and I can redeploy it too. Hang on 1 second here. Oh, there you go. So now has labeled Houston, Chicago, and once again, if I want to redeploy this, we can go ahead and do that. And everything is pretty automatic, so if I want to say Houston, Chicago, submit and give it a little bit of time to just evaluate everything. There you go. So now it has the labels for both cities on them.
Nice.
It was easy.
Yeah, I mean, that's one of the nice things about the Wolfram language is the code is very malleable. It's very easy to go in and make modifications, and since it's interpreted, you don't have to go through a compile step. You just evaluate and you get the new output, so you can very quickly go through iterations and develop things. I'd like to make just a comment about the output that you get on the cloud.
Sure.
So by default, what you get is not necessarily formatted really nicely. For example, when you deploy it as a PDF, you get a really tight frame around the contents.
Sure.
So you can add a little white space, for example, by using pane.
Pane, okay.
So if you just wrap your output with pane and specify image margins of some value,
Sure.
it'll give you a little more white space relief in there.
Okay.
You can also, you can go beyond that. You can, for example, there's a construct called framed. If you just wrap that with framed,
okay.
you also get a nice black frame around it.
Okay.
So, there are lots of features that you can use to style what you see in the cloud, and you can make very nicely refined, professional kinds of outputs.
And even something immediately like this. So if we want to deploy, like I said here, deploy the form function with your city 1, city 2. But then I specify the output to be a PNG, and I know that I could change that output to even be like, I know PNG ended up rendering kind of tight, but PDF might give it a little bit of extra wiggle room, like it might just be marginal, but if I try, like let's say, if we do output as a PDF, I just wanted to see kind of what that looks like, because then we could choose PDF, PNG, GIF, etc. Just one more time here. Chicago, Houston. I know these evaluations take a little bit of time, but
that one is quick.
It's all worth it at the end of the day, I guess.
These seem to be running a little bit slow today.
Yeah. So PDF ends up rendering it a little bit clearer, if I may say so myself. But
well, why don't you go back to your notebook and just try adding that additional formatting. So just wrap your TripPlanner there.
Sure. You're saying this call?
No, the definition, or you can put it right in the cloud deploy if you want.
Yeah, sure, I can do it right.
So just put framed of pane
on around where?
Around TripPlanner.
Okay. So frame. So like that?
Right, framed, open bracket, and then pane after framed.
So pane. Okay.
Okay, and then inside the pane, comma, image size or image margins arrow, I don't know, like say 20.
And now image margins, you're saying where would that go?
So that would go after TripPlanner.
Okay.
After the closing bracket for TripPlanner.
Okay.
Right, so comma, image margin 0.20.
Image margin 20.
Right, so that should do it, try that.
Okay, so now let's redeploy this again. But if this was a PDF, it would still, image margins would still be fine?
Yeah,
okay, perfect.
Whatever you have in there.
Oh, wow, nice.
Okay, there you go.
Perfect.
So that gives you a little bit of white relief. The frame doesn't come out so good because it's on a black background, but
yeah.
You get an idea what you can do.
Awesome.
Yeah. One other comment was, so what you've deployed with just the bare bones cloud deploy is accessible only by you.
Sure.
Right? So if you want the world to be able to look at what you've done, then you need to specify within cloud deploy, comma, permissions arrow public.
Or I can even, down here, I can say set permissions, and I could say accessible by everybody since it isn't.
Right, you can do that as well.
Directly do that. So, perfect. And now it's accessible by everybody.
Now anybody who's listening to this this event can, if you can type in that URL, you can actually go to what was just deployed and try it out.
Perfect.
Yeah. Several people asked about the fact that you had two versions of TripPlanner there, which were actually different functions, and that's one feature of the Wolfram language, which is polymorphism. So you can define different functions that have the same name, and it chooses the function according to the types of the arguments and the number of the arguments.
Right. So I would also say then, for even those who might be familiar with traditional-ish programming language like Java, let's say, that also supports polymorphism, that's a familiar feature that's available in the Wolfram language.
Right. It may have looked like a recursive call, but it's not actually recursive. Those are two different functions that just happen to have the same name. And it's a nice way of documenting that those are actually two aspects of the same function. Some other, you did some other things that were nice, just nice programming practice in what you did. Like, for example, using with to factor out the size so that you know, if you want to change the size, you don't have to change it in 3 different
Every
places
single
in the
time,
source
yeah.
code. And another nice thing is that you defined a function, the TripPlanner function, separate from the cloud deploy. I mean, you could conceivably just put the whole, you know, do the whole implementation inside your cloud deploy, but it's nice to sort of separate that. You can test it either in your desktop version, if that's where you're working, or in the cloud. And then when you're satisfied that it's working the way you want, you can deploy it with the cloud deploy.
Sure.
Mhm.
Yeah.
One thing you could add to this is some logging. You could, if you were interested in finding out, you know, what cities are popular, what trips are people planning, and, you know, because there's something I can optimize, you could always write the inputs to a file, keep a pen
Sure.
into that, and then go look at that later and maybe make adjustments on how you're doing things.
Definitely.
You could cache results if the same sets of cities are getting requested, you know, within a short period of time. or something.
Right. Very
So
cool.
this is just the tip of the iceberg of what you can do with cloud deploy. And you used a number of the data functions like icon data, weather data. There are scads of those. There's just a ton of information in the Wolfram language. There's country data, there's city data, there's element data, there's, I don't know, elementary particle data, there's just all sorts of stuff. And you can use those. I mean, you could use those here directly to expand your trip planner. For example, you can use country data to get at the electrical outlet type of the country. Get an image of that. You can use the mapping functions to put a map of your destination in the output. There's just all sorts of possibilities. I mean, Bob is the expert on a lot of those things. How the geographic functionality works in some of these data packlets. But there's a lot to draw on.
Absolutely. And I was going to say even something like, you know, getting the 2 cities' population, just kind of compare quick side by side or something like that, using city data, just extract a wealth of knowledge really that you can then just compare and really expand on the trip planner, I guess, here.
Right. Do we have any questions online? If you have questions now, you can go to the chat pod and type them in, and we'll try to answer what we can. Somebody had asked about whether this language is free, the Wolfram language. So anybody can go to the cloud and get an account for free, which has a basic level of access. There are higher subscription levels for the cloud if you're going to do some serious development. The desktop version, which is Mathematica or Wolfram Desktop, is a commercial product, a paid product. Although if you are a student, the student license is pretty reasonable. And if you're at a university, many universities have site licenses, so you can get Mathematica essentially for free at the university. The University of Illinois does.
Yeah.
Right. So students don't pay for it there.
And also, you guys can look at this page right here. Just give me 2 seconds. I'll go ahead and fire it up here. So you guys can see pretty much at any tier just to deploy to the cloud, whether it's an instant API or a form, et cetera. There are different tiers to deploy to. For the most part, for just kind of general recreational hackathon needs, if you will, you won't really need anything past the free tier. But of course, if you are starting to scale whatever you build, you can go ahead and do Explorer, Developer, Producer, if you start to actually make, I guess, company out of it and team, et cetera. So yeah, there are different levels that are available within the Wolfram Programming Cloud for deploying.
Yeah, let me just highlight a couple of other things that are online that might be useful to people. Okay, so if you go to, let's see, www.wolfram.com/language, there are resources for just getting familiar with the language. There's an introductory video here from Stephen Wolfram. And if you just are interested in examples, there's this code gallery here, which has a bunch of typical applications. Some of these also have cloud deployments in them. And so you can visit one of these. I think this was mentioned in the video. You can visit one of these. It'll give you an example of how to do something with the Wolfram language. Most of these are pretty basic, pretty simple. This is doing face detection in images. And then you can click here to, I guess this one's not yet live. You can click here, usually, to take that example into the cloud, and then you can play with it yourself there. For hackathons,
Yeah, I was going to mention this too.
right, there's a page here with that collects a bunch of resources that would be interesting to people who are thinking about using Wolfram things in hackathons. So there's information here on the programming cloud. The Wolfram language runs on Raspberry Pi. A lot of people are doing interesting device, hardware-oriented projects with the Wolfram language, and so on. And let's see. And there's also this page here, www.wolfram.com/cloud, that will give you information in general about using the Wolfram language in the cloud and getting online. There we go. So I'm looking here at questions that people have sent in. So one person asked, how does the city field in an input form handle misspellings? So those, if you specify a type like city, and there are lots of types, there's cities, there's countries, there's web addresses, all sorts of things. That's what we call a smart field, and it will actually interpret what you type in, try to interpret it as a city, and it's actually pretty robust with respect to misspellings. You can be pretty messy about it, and it generally does a good idea of guessing what you intend. That's a nice feature of those fields. It doesn't take any effort to get that functionality in your forms.
Right.
I can take another question from the chat room. Is the Wolfram language intended to be an easier way to develop web apps or programs rather than using HTML, JavaScript, PHP, MySQL, etc.? This is an interesting question because there's a couple answers. It's definitely an easier way to develop things on the web. The nice thing is that you can pick and choose. If you really want to, I think the power of it is kind of in the back end, which would sort of be the replacement for a PHP type of thing. But you can, for the front end, you can use, as we've been showing here, you can use a lot of Wolfram language stuff to make display artifacts, or you can, like PHP, you can generate all the HTML, CSS, JavaScript for your front end from the Wolfram language back end. A lot of the things that we see in the notebook, they're driven by Wolfram language and showing up in our internal HTML, CSS, JavaScript.
And I was going to even say that there is built in the Wolfram language connectivity to MySQL databases too, right?
Correct.
For people who go to hackathons, I work as a hackathon intern, so I go to hackathons on Wolfram's behalf. A popular thing that I've seen a lot of people use the Wolfram language for is to actually deploy instant APIs. They're instant RESTful APIs that you can then call from JavaScript or Python or whatever their kind of favorite language is. So that's a really easy, quick way to integrate Wolfram language with your favorite programming language, if you will, while still harnessing a lot of the built-in computations and knowledge that is built into the Wolfram language. Mm-hmm. So that's just kind of like a little side note, I guess. Mm-hmm. But yeah, do we take any more questions or kind of?
I think we have time for a few more, don't we? Yeah. One person asked about the Wolfram language on the Raspberry Pi. Actually, there are two related questions. So one person asked, what's the relationship between Mathematica, which comes on the Raspberry Pi, and the Wolfram language? So the Wolfram language is the language itself. Mathematica is one implementation of that. Another implementation is the programming cloud, and so forth. So Mathematica is the Wolfram language in addition to a development environment and a programming interface. So you can think of them as actually being the same thing if you're just thinking of the language aspect of it. About developing for the Pi, if you go to wolfram.com/community, there's a large community of Wolfram technology users, and I think on the right you'll see a topics bar, and there's a Raspberry Pi thread or a Raspberry Pi group. And there are many examples there of using Wolfram language on the Pi to control cameras, implement a weather station, all sorts of things. So I think if you're interested in that kind of thing, that's a good resource for you. There may also, I'm sure there's a web page online, I would guess, about that, but I don't know what that is off the top of my head.
And even on the wolfram.com/hackathons page, there is a little mention of Wolfram language connectivity to the Raspberry Pi, so you guys could definitely go check that out as well.
I'm looking for more questions here.
Is it possible to do an HTTP post in Wolfram language? Yes, from two senses. You can use the URL fetch function to make any kind of web request. You can specify the method as post. You can also write your instant API to receive post methods, or posts or gets or whatever. So yeah, that kind of aspect to Wolfram language is all there.
There's a question about using data input by the user in the Wolfram Cloud. There are lots of ways to do that. You can import data from a URL. You can import data which you have locally on your your laptop. There's a new thing we just rolled out called Data Drop, which is a repository just generally for data online. You can very conveniently drop data into a data drop bin, and then you can pull that in to, anywhere, whether it's on the cloud or on the desktop with the Wolfram language. That's one of the things that we've, making connections to data sources, to other programs, to whatever it is that the Mathematica or the Wolfram language might want to work with. That's one of our emphases, and we work very hard to make it easy to pull in data from all sorts of sources. Let's see what other questions we have. Who owns copyrights for apps deployed with the Wolfram language? You do. We don't have any claim at all on the things that you develop with the Wolfram language.
So I see a question here. I'm also new to programming, and I'm mostly overwhelmed by it. Is it the language is the language used in Wolfram language applicable or the same as Java, Python, and similar to MATLAB? So if you heard me earlier, I said more traditional languages like Java and Python. I think syntactically, Wolfram language is very different from those two. It's very function-driven. A lot of the data and variables, et cetera, that you get back are either entities or functions, whatever it may be. So I think in that aspect, it's very different from something like Java or Python. Syntactically, it looks a bit different as well. I think the best resources, though, for getting started about learning it, and I know I'm still learning it myself, I've only been learning it for a couple months, is really just check out the reference page, or it's like reference.wolfram.com, right? There are tons of examples in there, whether it's instant needs for just kind of deploying web forms or web pages, whatnot, to actually writing full applications in Wolfram language. It is sort of intimidating almost, like how much there is built into the language, but the docs are superb. There are tons of examples that you can go ahead and just play around with. So I think those are kind of just some ways to get started with the language. And once you start to get the hang of it, you'll see just how easy it is and how familiar the syntax can actually be. So I just kind of wanted to address that.
Mm-hmm. One person has asked about if you can do more graphically intensive things with the Wolfram language, including within manipulate. The graphics functionality in the Wolfram language is very strong, and you can do very sophisticated things. We haven't even come close to addressing what you can do. And anything that you can do within the Wolfram language, you can also do within a manipulate. Of course, you can always implement something which is going to take a long time to compute, and your manipulate will not be very responsive. But generally, you can do some very impressive interactive graphics things with the Wolfram language. And I think I'm getting the signal that we're out of time. So thank you, Alan, for a very nice demo, and thank you, panel. And thank you for attending, and we hope to see you at another Wolfram training event soon.